Welcome to Did You Know, the ESCO HVAC podcast, the show where we explore the cool, the hot, and the everything in between of the HVACR industry. Each week, we dig into the innovations, the insights, and the inspiring stories that power our trade, from the classroom to the job site and beyond. This episode is brought to you by this week's amazing sponsors: Daikin Comfort Technology, perfecting the air since 1924. Service Logic, people first, always. Hudson Technologies, 1 pound reclaimed is 1 pound not made. iConnect Training, supporting HVAC and refrigeration instructors, as well as the United Association of Journeymen and Apprentices of the Plumbing and Pipe Fitting Industry of the United States and Canada, built on excellence since 1889. Whether you're just getting started or you've been turning wrenches for decades like myself, there's always something new for us to learn. I'm Clifton Beck, and this is Did You Know, the ESCO HVAC podcast. Let's dive in. Hello, everyone. Thank you so much for joining Did You Know, the ESCO HVAC podcast. We've been spending a lot of time talking about transitions that we're making with equipment, with refrigerants, and sometimes we'll talk about the regulations and the driving forces behind that. So today we're spending some time with Audey Cash. How are you, sir?
Hey, good to see you. Good to be here. How are you?
I'm doing wonderful. I think I'm just about as confused as everybody else in the industry.
Join the party.
Yeah. Like we're all trying to stay up to date and we're trying to look for the right resources to make sure we understand how regulations and codes are changing, not just the installation environment, but even like the whole manufacturing side. And, you and I were kind of discussing some of the regulations that's driving this. We got a lot of ASHRAE committees and subcommittees, and we have guidelines and we have regulations, and some of that getting moved into codes. And we have some areas that have not updated their codes, and it's kind of a mess.
It's complicated. I'll agree with you.
Yeah. But when you have the right sources and you have the people that are dedicated to breaking it down and understanding it, there's a lot of partnerships being made in the industry right now with professionals who are trying to sort through and understand and share content. And that's very much what you've been doing for the last couple of years. So let's, I guess we can start on things. Let's just start on things like 90.1 or 62. Sure. Let's talk about some of the guiding forces within our industry and what's shaping those.
Yeah, your opening statement is true. There's a lot going on, and it feels like it can be like a word and number soup if you're if you're kind of new to it, or if you're kind of coming in and out, depending upon where you are in the design cycle for projects. One of the things that we've been spending a lot of time on is understanding how 90.1, which is really energy and energy code, drive decision making for building efficiency.
Yes,
and how the ventilation standards are trying to keep up with these energy objectives. And you do have challenges in certain markets and states in particular where the mechanical code or the energy code are kind of out of sync. ASHRAE does progress these forward in a purposeful way to try to help designers achieve higher and greater building designs and better building efficiencies.
Right.
But if they're out of sync, it can be even harder. But that's why we see some states progressing their mechanical codes now. About 20 states have adopted the 2019 version of the 62.1, which is a ventilation, so that we're catching up.
Right.
But that's a lot of states left. And, I think in the end, a designer, that's trying to design a building has got a lot of decisions to make. The mechanical code and the standards are the first place that they will go to get a good insights, I think.
Yeah, and I think a lot of the industry is unaware of the fact that across the country, we have standards and codes that do not follow consistency. And when we think about that, like we're talking about adopting 2019 standards, 6-year-old standards, now thinking about adopting 2019 standards. And so when we think about what's changed even since 2019, there's been a lot just in the last couple of years. And so we have manufacturers and engineers that are really struggling with, how do I build products that will be universally accepted and can fit some of these variety of different codes. And that's a difficult thing to do when you're a manufacturer, I can assume.
Oh, it really is. You know, I think if anybody's ever played hockey before, they know they want to skate to where the puck is heading. I think that's the hardest part, because, you know, by the time you design a product, launch a product, things are going to change.
Right.
And if you're designing for the 2019 version, eventually 2022, 25 will come along. And so you want to be as broad as possible. The good news is a lot of products that are in development are focused on energy efficiency. I think that trend started. And as long as you're focused more on energy efficiency, lower watts to do the same amount of work, you're moving in the right direction broadly, because we know that's what 90.1 is really driving us to, is lower watts per square foot in a design. And so alternative technologies, and we've seen the popularity of DOAS systems, or what we call decoupled systems, which obviously drive a lot of energy savings. And you see what we're driving towards is the indoor air quality procedure, which is reducing outdoor air by adding air cleaning, which of course can be a substantial savings, because outdoor air can be up to 40% of a building's energy use, right? Or I'm sorry, of an HVAC system's use.
Yeah.
So that's a lot of opportunity.
Yeah, absolutely. I just came back from an equipment manufacturer technical training, so I spent a week with Bosch as they're making this transition with the Johnson Controls and Hitachi team, and even looking at their technical training center that they have, their Ducted Systems Academy out in Norman, Oklahoma. We were talking about what equipment that they were bringing in. They're like, well, that whole corner over there is going to be DOAS equipment, because now we have to really start focusing on where can we educate on energy reduction and what type of systems can be implemented that will focus on that. And so, you know, they're lining up an entirely new realm of DOAS just because of things like this. So where are we in the industry, like, and where are we headed?
Yeah, so I think big picture, we are continuing to move forward with energy efficiency as a primary goal. Carbon reduction, which I think was more popular, maybe less so in the last couple of years, isn't really going away. Whether it's municipalities, some states, or even end users, it's just good practice. And I think where we're really going as an industry is to find the way to intersect between good energy efficiency and good return on investment. Am I applying my dollars in a practical way for efficient HVAC equipment? And the reason decoupled systems have become so popular and DOAS systems have become so popular is because they do ventilation fairly well, fairly cost effectively, and it reduces an indoor air quality concern, which is often too much moisture in a design or too much humidity. Building pressurization and moisture management is a big commercial concern. And so as these pieces of equipment become better, more sophisticated, able to lower the moisture content in the air as it gets delivered to a space, you get better designs, better, more efficient designs. And that's why I think that investment in that area, and really all going to this idea of ventilation being, and HVAC being, the number one concern from an energy perspective. So do that really well. See, the lighting industry went to LED, and suddenly they stopped. They were the bad guys for a while. Like the biggest watts per square foot were lights. Oh, not anymore. So HVAC is sort of in the crosshairs as the leading energy consumer. And so the idea of seeking strategies or equipment that drive efficiency is not going to be going away anytime soon. We don't see you don't see major technology leaps, right? You don't see 25% reduction in HVAC load. That's not a thing. Physics doesn't really allow us to do that. So we just try to find better ways to ventilate and condition buildings for these tighter sort of energy times.
Yeah, I believe exactly what you're saying. I believe that we are making that transition right now to focusing on the efficiency of the structure from the HVAC perspective. I just did a complete training series for a very large utility on the West Coast, because they've spent the last decade focusing all of their training efforts on LED light conversions.
Sure.
And they have determined that they have been successful with this 10-year campaign. And so now they're moving all of their efforts into education on building performance as well as equipment performance. And there's going to be a balance of understanding how to do that, because in the commercial realm, we have a lot of regulations on air management, infiltration, understanding how much external air to bring into a structure. We're working on that in residential. We have some areas that are already moving forward with their own requirements for fresh air based on the tightness of the home. So the residential realm, which a lot of our audience today, and I'm glad that everyone's joining us from the residential sector. We do have some commercial technicians as well joining us. We have engineers, and I'm wanting particularly our residential consumers to understand that we're moving into a place where it's going to be required for you to understand the quality of the air in the structure and how to, like you were saying, reduce some of that air that you're bringing in because of the amount of energy it costs to not just bring it in, but then to treat it. Like any air we're bringing in, we're going to have to dehumidify, we're going to have to temper. So how can we do a better job working with the air that we have? And that's really been your focus for the last few years.
Yeah, spot on. I think I'd say the transition on the commercial side will be a lot of conversations about ventilation and making sure ventilation is appropriately balanced with the needs of the space. And one of the best areas you can do that is to balance your outdoor air with indoor air cleaning. And if you can, and the one thing that ASHRAE has supported for 20 years or more, and frankly doesn't get enough adoption, is this idea of balancing outdoor air and air cleaning.
Yes.
So that you can reduce outdoor air, which will lead to, sort of, I would say, incredible equipment savings, return on investment, those kinds of things. And in any existing structure, especially older buildings, bringing in more outdoor air may not even be easy to do. Like you almost literally have to make a bigger hole in the building. And that doesn't go over well. It drives cost, right? And I think, as you point out, Clifton, in people's homes, indoor air quality is sort of an afterthought. We think about temperature, we think of humidity. Maybe those are the things that we could feel comfortable at home. But one of the things that we're trying to move forward, to your point, is how well is your system or how well is your home ventilated? And so we're bringing more and more air quality monitoring, measuring, and responsiveness even into homes. It used to be, I'd say, that's mostly a commercial thought process. But it's not that expensive anymore. The cost of sensors, like the miniaturization of sensors and sensing technology, is right here today.
Yeah.
And so homeowners can be informed. The one thing that we've been talking about, and we haven't frankly launched it yet, but this is early days for us. But one of the things we've been talking about is making a third number. People pay attention to temperature, they pay attention to humidity, but what about your indoor air quality score? Like how good is your air?
How good is the air? I agree.
Yeah. And it's frankly not hard to do. And as we've done studies out in the real world with real people's homes, it's disturbingly bad at times, and people don't know. So we will see some major progress, I think.
Yeah,
particularly as you look at ventilation.
Yeah, well, and we look at the quality of the air outdoors. It's not like the air that we had, 50 or 60 years ago, where we preferred bringing in all of our outside air. And many times we're talking about, manufacturing environments. We're talking about commercial buildings that are in, high volume areas, and that outside air may not be as good as what we would think that it is. And, many parts of the world, particularly if you look at the Asian homeowners, it's a norm to have indoor air monitoring so that they understand how to better treat the air internally. And you're right, it's just now starting to become more of a standard. I've been working with a lot of OEMs as well as third-party companies in the industry that are, very much about performance, system performance. And it's intriguing the amount of conversations that start out as system performance that lead directly into air performance. Air is the driving force behind our comfort, no matter whether you're a ducted system or a ductless system. And so the air that we're moving, it's critical to understand what is that condition. We always talk about we're in the job of moving heat and we're in the air conditioning business. Well, what are we conditioning? I think it's important that we understand what we're actually working with before we try to treat. It's kind of like a doctor, someone going into a doctor's office and going, I don't feel good. And the doctor says, let's just throw everything at you and we'll hope that you feel better.
Good luck with that approach. That'll cost you a lot, I think.
It will cost you a lot. And sometimes creates, byproducts that are even, more toxic than the original conditions. And so
when the cure is worse than the disease, right? So I will just to play on your comment a little bit. I think that there's something really interesting about this idea of urbanization and living in cities and living where it's convenient to walk versus drive. And there's a lot of that going on. And a lot of people live in more densely urban environments, particularly throughout the world, but in the United States increasingly. Cities are one of the one of the challenges around air quality. We have ozone alert days.
Mhm.
We have other PM, so particulate matter. And this has been a common thread, I'd say, over the past 2 years of any article I see on air quality. We focus on particles, and that's really important. Particles, PM 2.5, those that are 2.5 microns or smaller. PM1, really, 1 micron, like these ultrafines, are about 70% of the health concerns come from those kinds of particles in our breathing zone.
Mm-hmm.
So, if you think about 80, 20, 70% come from particles. The next bit comes from something like formaldehyde, which, is a building material, off gas. These things are not easy to manage. They're invisible to see.
Right.
But it starts with good equipment maintenance. It starts with good filtration in your home, especially if you live in an urban environment. And so you look at these particles, and they're really supposed to be captured by good filters.
Mm-hmm.
But how well do you know how well is it working? It's hard to know. And now we're bringing, I think, more and more sensing to that conversation so that you can see it and make good decisions. But anyway, I digress a little bit, but I think
that's great.
The whole concept of air quality and measuring for the contaminants that matter is what ASHRAE is moving us towards. Mm-hmm. So, we talked about earlier about the 62.1 in 2019 and the mechanical codes. Since 2019, I don't know if anybody's been paying attention, there was a global pandemic. So like the whole HVAC world kind of got turned on its head because part of the reason why the pathogen gets spread in a building is because we move air, right? And so we had to get better as a business, better as an industry, and we did. And so there's been updates in 2022 and 2025. And all I can say is that the standards for residential, 62.2 and 62.1 for commercial, have large amounts of information in them now focused on indoor air quality. And that procedure, which focuses on managing particles and these gases that are impossible to see. And all I can say is, if you follow the procedure, you'll have healthier indoor air. Mm-hmm. And we just want to make that visible and visual to people so they can make good decisions. It's really an opportunity, and it does directly impact a lot of people's lives, right?
Yeah. I think about the homes that we're building. We always think about a newer home being a cleaner environment, being a more fresh environment, because we're making them so tight. And, so the home that I'm in, it's now 5 years old. We moved into it new. One of the first things I did was start looking at, air monitors. And so I have a couple different air monitors that I have worked with from manufacturers, tool manufacturers and test manufacturers. And we were very intrigued when we started looking at the air quality indoors, recognizing that our indoor air quality was significantly worse than our outdoor air. We had a lot of off-gassing. We had a lot of contamination. And so we have to really change our mindset and think about construction trends that have changed. We always talk about, we need better windows, we need better doors, we need tighter homes, we need less infiltration, we need better vapor barriers. But in that process, we're removing a lot of that cleaner air or fresh air in many cases that we used to rely on in a home. So it's critical that we understand the standards for that. And I know that it's not required in our residential applications yet, but at least we have some of our ASHRAE standards that are leaning us into that. And we do have jurisdictions that are now requiring us to bring in fresh air and to treat it in homes that are too tight and need that additional ventilation.
Yeah, this is the example of efficiency is driving a secondary effect that may not be what we intended, right? So building efficiency, home energy efficiency seals the building up tight. And while we've kept the outdoor out, which is generally, sometimes a good thing, right? Especially from a temperature and humidity perspective, and wildlife, I guess. But as you do that, you have to kind of look in the mirror and realize you're the number one contaminant of your air. Right. The activities that we partake in, even just digestion and respiration, we do pollute our own indoor air. We are the leading cause of pollutant in the home, by the way. And of course, if you have dogs and cats and kids, and you have them all look in the mirror because they're part of the problem. And so ventilation and doing it efficiently is really key. And bringing in outdoor air and exchanging outdoor air, so like bathroom exhaust fans help with this process, right? So the 62.1, the latest, I'm sorry, 62.2, the latest residential standard from ASHRAE does include pretty hardy guidelines on indoor air quality and how to manage that better in your home. I know it's not required by code anywhere, but if I were building a home tomorrow, I would certainly break the code out and spend some time looking with my HVAC technician saying, what would it cost me to do X, Y, or Z? Yeah. And some of it's temperature, humidity for sure. Some of it's ventilation, and doing energy recovery ventilation is a reasonable approach. My brother, who lives in Minnesota, does that in his home. They just built a new home. And so, they have several kids in their house. They want good air quality, and they don't want the energy bill necessarily to open a window, right?
Right.
So there's especially in Minnesota in the winter. And so there's a good balancing act that can be struck here when you look at the guidance and the direction that the ASHRAE standards can bring to you.
Yeah. Before I actually started pursuing this educational career within industry, I was a technician and a contractor for a couple decades. And I can remember early in my career, so I've shared this story with some friends and they always get a kick out of it. It was probably 2010-ish, somewhere in that ballpark. A local friend of mine, he was a mechanical engineer, was building his own home. He was the general contractor. And that was when we were starting to talk about high efficiency systems and high performing homes. And so at the time, encapsulation was the conversational piece. So he wanted to build the tightest home that he could with the least heating and cooling capacity. Built a really nice 2-story home with a full basement that had, like 14-inch thick insulated concrete walls, encapsulated the entire structure all the way up to the roof decking, the best windows, best doors he could. Load calculation on it was very minimal, had a geothermal system. And so, he did all of the construction of it, following what codes were available in our area, didn't have any type of an ASHRAE standard for air quality at the time. And shortly after Thanksgiving, he gave me a call and he said, hey, what do you know about air quality? And I said, well, I deal with a fair amount of air quality. He says, is there any way to measure and to help me get some ideas of what's going on? I said, well, what's the problem? And he says, well, it's kind of embarrassing. I was like, I'm a contractor. I'll be very professional about this. What's your concern? He says, I can't fart in my own home. And I said, okay, that's not exactly what I was anticipating the conversation to be. He says, just as an example, he says, any type of fumes in my home will be there the next day.
Yeah.
He said, I can't run my fireplace because it chokes itself out in about 2 or 3 hours.
Wow.
My windows have so much condensation, I cannot boil water in my home.
Wow.
What do I do? I said, well,
you need some makeup air.
You need a lot of makeup air, and it's going to change your entire load on your structure, and it's going to have to be recalculated into your system.
Yeah.
And that was the beginning of my curiosity with air quality and the ways that we can combat these tighter constructions. And it's crucial to have guidance. And I use that example all the time because it always gets a little bit of chuckle out of somebody. But the truth of it is, as we build these tighter homes, there are consequences.
Sure.
And as professionals, we need to understand what they are and where the resources are to learn about them.
Yeah, I think, for your audience, anybody kind of tuned in on this topic right now, I would say the first thing anybody has a concern about with air quality in their home, it's run your system more. Particularly in shoulder seasons. It depends on where you are in the country right now, whether it's really cold outside or not. I'm in heat pump zone. We're running the heat because it's nice and cold today. But if you're not running your system, you should be circulating the air in your home. I mean, that is number one, because air does get stale for sure. And not having air changes is the first biggest concern with air quality, right? So start moving your air around. It allows particles to get through filters that are built into your home for a reason, to help protect your air. And then if you do have concerns like you're talking about, whether it's odors or primarily odors or particles or pathogens that are concerns, there's electronic air cleaners, and there's always better filtration that you could step up to if your system can support it. And that's where you probably need to get the support of your technician who knows how to do the math on that, because you don't want to do too much static pressure on your system, because then you got second problems.
Exactly.
But move your air. Like, if I could make one recommendation, it's move your air. We do testing in people's homes with our products, and whether it's ions or UV lamps or filters, they don't do any good if the air doesn't come meet them. So you got to move the air. pass these devices to actually have an impact with your electronic air cleaners or filters. And so that's a big deal. And I purposefully changed thermostats out in my home to get to one that I can set it to run at least for 15 minutes every hour. It's smart enough to just circulate. Yep. Even if it doesn't need to condition, it still moves the air. And we've done the math. It's $1 to $2 a day just to move it without conditioning load.
Right.
It's not going to break the bank, and I think your air will get a lot better because of it.
Absolutely. Audey Cash, I sure appreciate you joining us with some really good education and information. Where can we learn more about your involvement in the industry, your products?
Yeah, for sure. I'm the CEO of GPS Air, so it's gpsair.com, easy peasy. And for those of you that are interested, I'm kind of always doing presentations out on the road. But our LinkedIn page. So if you find GPS Air on LinkedIn, you can see all the upcoming training opportunities you have on 62.1. I'm actually doing an advanced course on the indoor air quality procedure next week, and then the week after that we actually have a big product launch. But anyway, tune in to us at gpsair.com or our LinkedIn page.
Very cool. I really appreciate your time and your education today.
Thank you very much. It's always a pleasure. Hope to be back soon.
Same here. Thank you.
Thank you.